Hi, I'm a master's student majoring in computer science, and today we are going to be talking about why to evaluate the machine learning model. So, we're going to be discussing a couple of things today, which is confusion matrix, accuracy, precision, recall, specificity, F1 score, precision recall or PR curve, and the ROC curve. These are a couple of things that are very important when it comes to machine learning, and you need um, to do these things to provide like an analysis on how your model is working and if it's able to successfully classify, well, if you're doing image classification, if it's successfully able to classify a cat as cat and a dog as dog, which is a famous one to do. So let's get started. We have a confusion matrix. So it's as simple as it sounds. It's like what percentage of the time it's getting confused and what it is getting confused as. So it just gives you an information about, hey, this is supposed to be cat, but it is identifying it as eagle or dog or whatever, on based on how many ever values you're testing. So you have true positive, false negative, false positive, and true negative. So you want your green spheres to be as high as possible and blue spheres to be as low as possible. There's a spheres, rectangles, or entities. So true positive means that the image is of a dog and your model correctly identified the dog as a dog. True negative is the image is a dog. True negative is the image is not a dog and your model correctly identified it as not a dog. It's kind of the same thing, but not really. So in true negatives, you're looking at the inverse kind of it. You can say like not like this, like it was able to successfully reject it that okay, this is not a dog. So yeah, again, you want your greens to be as high as possible, blues to be as low as possible. All right, what is your false negative? So it says so your image is not a dog, but it identified it as a dog. And your false positive is your image is a dog and your algorithm failed to recognize it as a dog. So it's a little difficult to get it at first, but if you consider an example and if you go with the example, it becomes pretty easy as well. But yeah, your diagonal, which is the green diagonal, should be as high as possible. So like with confusion matrix, if you get confused yourself with what is what, you just need to make sure that your green diagonal has the highest value it can get. So let's talk about accuracy. So you have your true positive plus true negative by everything, which is true positive, true negative, false negative. So the most commonly used metric to judge a model, but here's the thing, accuracy is not everything, which is why we have other parameters also to say, other parameters also give a clear example of what the ML model is, because it could be that your model does not completely depend on accuracy. So there are cases in which having a highly accurate model is good, and then there are cases where you don't need accuracy as much. So then you have precision, okay, so which is true positive by false positive. So if you can say what is precision, if you can imagine like a dart board. So instead of saying that all of your pins hit the red, like hit the bullseye, you're saying all of your pins landed in the first quadrant of the dartboard. That saying that is having a highly precise model. Like the result can be false, it can be true, doesn't matter, but most of your observations are at this clump, this particular area, and that is what it means to have a precise model. So recall, or it could be sensitivity, or it could be true positive rate. All of them is the same thing. So percentage of positive instances. So recall is just everything like it's true, like how much of your model is coming back, like how much your model. So it's not exactly accuracy, but it is saying it's saying how sensitive your model is, or how high is the positive rate of your model. Specificity is how specific of an answer you how specific is your model in the output it is generating. So it's the total actual negative instances, meaning that uh, how much of it was like it was correctly able to identify that it is not a dog. Out of all the dogs and other animals in the data set, how much of it was not a dog? How specific a result you can get with your model. Then you have your F1 score. So this is just a formula that says harmonic mean of precision and recall, and it's a trade-off between precision and recall. So your model can be highly precise, but it can have a low recall rate, and if it has a good recall rate, it does not have a good precision. So all in all, it takes in both precision and recall as a whole, and if you have a really good F1 score, it means that your model is really good. Then you have your PR curve. It's a curve between precision and recall for various thresholds. So here you've plotted your precision and your recall, and you need to check which one of the curve is pretty good. So I would say that so these are like all pretty good results. You're never gonna get a straight um, line between precision and recall, but having a curve that corresponds to such curves is pretty good for a PR curve. And then you have your ROC curve. So if you look at your true positive rate and false positive rate, yeah, here you have another dependency. So false positive rate is 1 minus specificity, and true positive rate is nothing but recall. So it's plotted against your TPR and your FPR, and it shows how they correspond together. And thank you for watching this video.